Test, test. All right. Okay, so hello everyone, welcome to the OneClass channel. My name is Andrew, and I'm currently doing Stat and Math at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in our description below. So now let's start our session. All right. Okay, so our first question today, let me just zoom in a bit, is asking us what is the associative property. All right, so let's copy down the question. What is the associative property? All right. So the associative property is a property in addition or multiplication which state that the result of the operation will be the same, even if we change the arrangement of the parentheses or the grouping. So now let's write down the keywords. It's a property in addition or multiplication which states the result will be the same even if we change the arrangement of the parentheses or grouping. Yeah, so that's sort of like a definition of what it is. And then coming up, we have our formulas, or we see the symbols. So A plus B plus C, if we're grouping the first two, will be the same thing as we grouping the last two. So A plus B with a bracket plus C is equal to A plus B and C. Yep. And also in multiplication, it's going to be A times B times C is equal to A times B times C. Yep. So it's exactly the same thing. And now let's say we got another example. Let A is equal to 1, B is equal to 2, and C is equal to 3. Okay. So now let's prove that the property is still correct. So let's do A plus B plus C. So the first time we're grouping the first two, which is A plus B. So A plus B is 1 plus 2 plus 3. And this becomes 3 times 3, which gives us 6. And then let's do the grouping for the last two. So the equation becomes to 1 plus the sum of 2 plus 3, which is 1 plus 5, which is still going to be 6. So now we can see the left-hand side is equal to the right-hand side. So which means that proof that the property is correct. And also, just let me see the question again. Yeah, so now in terms of multiplication, if I times the first two and then times C, that will be 1 times 2 times 3, which becomes to 2 times 3, which is 6. And then if I multiply the last two terms first, which is 1 times 2 times 3, with a bracket on 2 and 3, so we will have 1 times 6, which is still going to be 6. So which means the associative property can also be applied to multiplication. Right, so now we finish proving this part. So yeah, so I think that's all we have for this question. Okay, so let's leave a comment there. All right, so our second question is asking us what is the volume of a cube, or what is the formula? Okay, so first let's draw a cube first. Okay, so a cube looks like this. Yep, so that's a cube, and it is 3D solid that consists 6 square faces whose adjacent faces are perpendicular to each other. So let's write down the key characteristics. 3D solid consists of 6 square faces. So these are all the faces are square. No, I think so. Square, 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 which means all sides are equal. Yep. And adjacent faces are perpendicular to each other. Right. So in terms of the volume of it, so volume is the amount of space inside the certain 3D figure. And generally, the volume is determined by the number of blocks or cubes of a unit length that can fit inside the space. All right. So to determine the volume, we must determine the number of cubes that can fit inside a solid. So let's call, let's get rid of this blue line. So let's say we have a length denoted as little s, and a height SIS, and also the width SS. Yeah, and since they're all squares, so that means every single side, the length of every single side is S. Yeah, so S everywhere. Yeah, so therefore, the volume is just going to be equal to S times I S times S. which is going to be s cubed, where s is the length of one side of a cube. Yep. So that's all we got for this question. Oh, and how about we just practice this with an example? So let's say we need to calculate the volume of a cube with side length of 4 centimeters. Yeah, so we just need to simply substitute this into our formula, which is given by v is equal to s cubed. So in this case, our side length is 4 centimeters. So it's going to be 4 to the exponent of 3. So we have 4 times 4 times 4, which is equal to 16 times 4, and which gives us 64 centimeter cube. That's our volume. Yeah. Okay, so now let's leave the comment. Solution square root done. Okay. And for this question, because the junior tutor gave us the graph of the unit circle, so I'll just use this to explain this and go over the steps. So the tangent is defined y over x, and so it is a ratio of the vertical line and horizontal line formed by a certain angle to a point in the unit circle. So for example, we take tangent 30 degrees. All right. Okay, so still I'll draw the graph on my paper as well. So 30 degrees. So here's a 30 degrees, and that's our unit circle. Okay, so that's one. So at this point, like the green point right here, the coordinate should be √3 over 2 and 1 over 2. And I'll just write pi over 6 here as well, because pi over 6 is just 30 degrees. Right. And yeah. So knowing that the x and y coordinate for 30 degrees seen from the unit circle is given as 1 over 2 and √3 over 2. Oops. The x coordinate 30 degrees. Wait, hold on. Just let me check. So yeah. So I think there's a typo there, because the x coordinate should be √3 over 2, and the y coordinate should be 1 over 2. Yeah. Right. So the tangent, I'll write it down here. So tangent pi over 6 is just equal to tangent 30 degrees, which is equal to 1 over 2 over √3 over 2, which is equal to 1 over 2 times 2 over √3. And we just cancel out the 2. So we have 1 over √3. And we just simplify this radical. We times a √3 on both denominator and numerator. So we'll get √3 on the top and 3 at the bottom. So therefore, root 3 over 3 will be our answer for tangent 30 degrees. Yep. So now let's leave a comment there. I mean, the junior tutor's answer is still correct. I think he just didn't write the correct order for x and y coordinate. Yep. So x coordinate, let's leave a comment. X coordinate should be root 3 over 2. Well, the y coordinate should be 1 over 2. Answer is still correct. Well done. All right, coming up, we have the transitive property of equality. Okay, so now let's write it down. Transitive property of equality. Yeah. Okay, so this property tells us that if two elements are equal and the second element is also equal to a third element, so then the first and the third elements are also equal to each other. So by using the symbol, let's say if A is equal to B and B is equal to C, then we can conclude A is equal to C. Right. So in other words, A has a relation with B and B has a relation with C. So now we can conclude that A has a relation with C as well. And since A is equal to B, B is equal to C. So now we have A is equal to C. Right, so given examples could be, let's say, A is equal to B. So given A is equal to B and B is equal to 100. B is equal to 100. And we're asked what is the value of A. Right. So according to the formula, we have A is equal to B, B is equal to C. So that means A is equal to whenever the value that is equal to B, and in our case it will be 100. So the value of A will be 100, and that will be the answer for our example. Yeah, so that's all we got for this part. Let's leave a comment. Okay. Good job. All right, so coming up, we are asking what is the limit definition of the derivative of a function at a point. Okay, so the limit function of the derivative of a function is given by, the limit definition. So limit definition of the derivative of a function is given by the derivative of fx is equal to limit as delta x approach to 0, fx plus delta x minus fx over delta x. And if we want to find the derivative at a certain point, it could be when x equal to 1, x is equal to 2, x equal to 3. So let's say at a certain point, x is equal to a, where a is a constant, and we now have the derivative of fa is equal to the limit still as x approach to 0, fa plus delta x minus fa over delta x, or we set delta x is equal to x minus a, we will get derivative of fa is equal to the limit as x is approached to a, fx minus fa over x minus a. Yep. So this is sort of like the definition, the limit definition of the derivative of a function at a point. Yeah. Okay, so now let's leave a comment. Solution is correct. We're done. Okay. So now we're asking, what are the basic rules and formulas in calculus? Okay. So I'm assuming that this question is more focused on the differentiation part. So let's write it down here. Basic rules and formulas. All right. So we can solve for the derivative of the most common functions using the following formulas. So the first one, let's talk about the constant rule. Constant rule, which means the derivative of a constant is a 0. So where c is a constant. So some examples could be, let's say we take the derivative of 6, it's still going to be 0. And we take the derivative of 100, still going to be 0. So derivative of 250 is going to be equal to 0. So as long as we're taking the derivative of a constant, it's going to be equal to 0. So that's the first basic rule. In the second, we got the power rule. Power rule. All right. So let's say we need to take the derivative of xn. So in this case, first we need to move the n in front to the coefficient position of x. So that becomes to nx, and we need to minus 1 our exponent part. So that's sort of like a two-step. So first, we need to move n in front of x. The second, we need to minus 1 on exponent, our original exponent. Yeah. So next we have the product rule, which is given by if we want to take the derivative of fx times gx, and this is going to be equal to fx times the derivative of gx plus gx times the derivative of fx. Yep. And we also have our quotient rule. So if we want to take the derivative of fx over gx, we'll have gx times the derivative of fx minus fx times the derivative of gx over gx squared. Don't forget the exponent on the denominator, so that's not gx but gx squared. Okay, and also what other things we have? Oh, and also the chain rule. So if we need to take the derivative of fgx, which means gx is in the function of fgx, and this is going to be equal to the derivative of fgx times the derivative of gx. Yeah. So we need to take the derivative twice in the chain rule. And in terms of trig functions, so the derivative of sine x is equal to cosine x, and the derivative of cosine x is equal to negative sine x, and the derivative of tangent x is equal to secant x squared. Yeah, so and in our log function, the derivative of ln x, it's just going to be equal to 1 over x. Yep, so I think that's, yeah, we covered a lot, basic rules and property in differentiation. So now let's leave a comment there. So solution is correct. Yeah, so I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, please read the links in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from OneClass. Hope to see you soon.